Hi and Assalamualaikum. So we are going to present about the queuing system at EcoShop U Central Segamat. Okay, now let's meet the group. Okay, my name is Ahmad Zuhdi bin Azman and this is my another group members. So I will start with the introduction. The location of EcoShop is A008 U Central Segamat, Jalan Utama 3/2, Taman Utama 8500 Segamat, Johor. Next, the operating time is 10 AM until 10 PM. Then the observation time that we chosen is from 2 PM until 3 PM. And lastly, the number of EcoShops in central server is 2 server.
Next is characteristic of the queuing. For the first characteristic of the queuing is arrival characteristic. There are three types of arrival characteristic, which is size of the calling population, pattern of arrivals at the system, and behavior of the arrival axis. For the size of the calling population of EcoShop is unlimited, which is essentially infinite, where the number of potential eco-customers seeking service is so large. For the pattern of arrivals at the system of EcoShop is Poisson distribution, where 48 customers per hour. And behavior of the arrivals exists at the EcoShop is patient, where the customer at EcoShop wait in line calmly until it's their turn to be served. Next, we move to waiting line characteristic. There are two waiting line characteristics, which is the length of line and queue discipline. For the length of line in EcoShop is unlimited, where there is no maximum limit to the number of customers that can wait in the queue, and Eco customers can continue to join the queue even if it becomes very long. For the queue disciplines of EcoShop is FIFO, which is first in, first out, where the Eco customer that arrive first at the payment counter is the first one to be served.
Next, I will explain about the service facility characteristics. Firstly, the service system configuration of EcoShop has multi-channel system, in which it has 2 servers. Second, the service is a single-phase system, which means that the customer will be served at only one counter to make payments for the purchase of their products. Third, the number of waiting line is multiple lines, as each of the server will have a line. The assumption for the pattern of service time follows the exponential distribution, in which the mu is equals to 28 customers per hour, which means that the server took 2.14 minutes per customer on average in 1 hour. Then, for the basic queuing system configurations, we can indicate that EcoShop has multi-server, multi-line, and a single-phase system. Based on the diagram, the customer will arrive and queue in the line to make payment at the counter, which is the service facility. Then, the customer will exit the EcoShop.
Okay, here the result of our study. So, as you can see, our mu, the service rate, which is 28 customer per hour, and our lambda, the arrival rate, 48 customer per hour, and our server, which is 2. And there's certain assumptions need to be met. And some of them is every arrival rates to be served regardless of the length of the line. So we assume there is no bulking, no re-magic, and no jockeying. The next assumption is arrivals are independent of preceding arrivals, but the lambda, the arrival rate, doesn't change over time. And second one also relates to the mu. The service times also are independent of one another, but their average rate is known. Okay, so we move to the calculation part. The first thing we need to calculate is the utilization factor for the system, which is P. Okay, the formula is lambda over server multiply mu. So we substitute the number and we got 0.8571. This is the probability that the service facility is being used. The second one is the percent idle time, which is P0. So the formula is quite long. We just substitute the mu, the lambda, the server, and then we get the 0.0769. So this is the probability that there is no customer in the system. So it's nearly zero. Okay, next, the average number of customers in the queue, which is LQ. The formula not quite long. It is P multiple lambda over mu, power of S over, and multiply by P0 over server factorial multiply 1 minus P power of 2. So after substitute all the numbers, we got 4.7427. So this is the number of customers. Since this is a person, so we can set up, we can round up to the 4 customer per hour. So the next one is the average number of customer in the system, L. Okay, the formula is LQ plus lambda over mu. So we got the answer 6.4570. Same with the above. Since this is percent, so we assume there is 6 customers per hour. Okay, the average time customer spends in the system, W. The formula is L, which is the number of customers in the system, over lambda. We got 0.1345. This is the answer in the hour. So we need, if you want to answer in this minutes, we just need to multiply by 60. So we got 8 minutes. Okay, the last one. The average time customer spend waiting in the queue, WQ. Okay, the formula is LQ, which is the number of customer in the queue, over lambda. And we got 0.0988, which converts to the minute. It is 6 minutes. Okay, in order to check if our calculation is right or wrong, we can use QM for Windows. So, under queuing line, you get the waiting lines result. So, here we can check our value, is it same or not. So, the value which is in the hours, same as our answer, and also they provide the answer in minutes also. Okay, other than the waiting lines result, we also get the sensitivity number of servers. Here, the QM for Windows manipulate the number of servers. So it shows the value of LQ, L, WQ, W. If the server is 3, 4, 5, and 6. Okay, next we got the table of probability. This is the probability if the number of customer is 0, 1, 2, 3, 4, 5, until 30. Okay, so that's all for me. Thank you.
So last but not least, I will wrap this video with the conclusion. So comment on the number of server provided and the customer waiting time. Is the number of server provided adequate? Yes, it is true since the rate of customer service exceeds the rate of customer arrival. Then, is the customer are happy with the waiting time? Yes, they will be satisfied because they won't have to wait around for too long to be served. And lastly, describe what you have learned from doing the object. For me, if the mu is greater than lambda, that means the server provided are enough to serve the customer at a fast rate. And then, if the lambda is greater than mu, the server cannot handle too many customers. Waiting time and the waiting time increase because of the pool of server.